hot. Awesome. Now, I'm going to make a very short introduction, a couple of minutes, to the Cyprus Software Craftsmanship Community. It's a very new community. This is our first ever event. It's nothing new. There are communities all over the world, in London, in Paris, in Berlin, all over the US. And these communities are basically communities for people, for software people, software developers who really care about the result of their work, about the software that they craft. And of course, we are a group of people who want to share their knowledge and learn from each other, and are inspired by the Manifesto for Software Craftsmanship. Feel free to like our pages on Meetup and on Facebook. We are going to announce some very cool events in the upcoming days as well. So make sure that you subscribe to those events. And in case that you want to share something with the community, to share your knowledge, get in touch, and I would be happy to have a talk with you. Thank you so much. Uncle Bob, the stage is yours, and everybody hold well. Thank you so much.
All right, so let me see if I can work this Zoom thing here. I can't share my screen. You're gonna have to let me share my screen.
Okay.
You'll have to make me a host or a co-host or something.
Is that okay now?
Yeah, that works.
Awesome.
Good. And let's do this, share that. And I believe now you see on your screen the words expecting professionalism. Let me see if I can get rid of all that. Maybe I can shape this window a little bit. Good. Okay, so this is a talk that I have given many, many times in many, many places. It is about craftsmanship in general. It's about being a good software developer, but it's told from the point of view of a CTO, a Chief Technology Officer. And in fact, I want you to assume for the next hour that I am your new CTO. I am going to tell you what I expect of you. Now, let's be very clear. I would not make a good CTO. I'm a programmer. I don't want to manage anything. It's enough for me to manage my two hands at my keyboard. So I don't want to manage anybody else. But if I were a new CTO, if I were your new CTO, then I would have certain expectations of you. And those expectations would be about professionalism. I'm going to go through a list of what my expectations are, but before I do, let me just talk a little bit about this word, professionalism. Do we, as programmers, have a profession? Now, in order to have a profession, there must be something that we profess. What do we, as programmers, profess? Do we have any standards? Do we have any ethics that is particular to programming? Do we have a set of disciplines? Is there something that we profess, or do we just kind of throw code around? and at the moment, we just kind of throw code around. There's no defined set of standards. There's no defined ethics. There's very few defined disciplines that one could associate with a profession of programming. I know we'd all like to consider ourselves professionals, but a professional must have something to profess. Now, we need to be a profession. We need to be a profession because our civilization depends on us for its existence. That may sound a little extreme, but it's probably not, at least not anymore. 30 years ago, we could have said that human life would continue without software developers. Today, I'm not at all convinced that that's true. I want you to look around. Look around your room. Look on your clothes. How many things attached to your body have a processor in them? I'm currently holding my iPhone. My iPhone is clipped to my belt, and my iPhone has many processors in it. There's the processor for the graphics, and there's the processor for the Bluetooth, and there's the processor for the cellular phone, and God knows what else. There's GPS in here. There's all kinds of stuff. Lots of processors, tons of software. How many lines of code do you think are running in this iPhone here? It's got to be hundreds and hundreds of millions. But maybe the most surprising aspect of this is the fact that the iPhone is sitting inside a case, and the case has a processor in it, and the case has code running in it. Some software developer wrote code that's running inside the case of my iPhone. I mean, things have gotten to the point now where we put processors in the cases. I have, I've got AirPods, AirPods, whatever these things are, in my pocket. These are the old type of AirPods. I don't know if you can see them on the screen. You'd have to look at my picture, but there they are. And there are processors in there. A lot of processors. There's at least one in each earphone. There's probably one in the case. There's one in the case. It's a processor in the case, right? And I got my car keys. My car keys here. I don't know if you can see them, but they're sitting on my belt. My car keys have a processor in them, so they can talk to the car. And I got my Apple Watch. I got a couple of processors in that, and I don't know if there's anything else on my body that has a processor in it. Maybe, I don't know. But then you look around the room. Now, my room is a little bit different, perhaps. I've got a lot of processors sitting there behind me. They got a flight simulator back there. You may have noticed the little blinking light thing over here in the corner. That's a little PDP-8 emulator that I picked up once, just to have it decorating my office. I have a processor sitting there, and it's nothing more than a decoration. I have many other processors around the room. There's my thermostats on the wall. If you go up to the kitchen, there's processors in the microwave oven. There's processors in the dishwasher. There's processors in the washing machine, in the dryer. Let's see, guys, you're gonna have to mute your microphone unless you are trying to talk to me. Mute your microphones, otherwise everyone will hear what's going on in your room. Let's see if I can control a microphone. No, I can't seem to. Anyway, lots and lots of processors everywhere in the house. If you drive a car, how much software do you think is in that car? Modern car has about 100 million lines of code in it. Now, I'm not talking about a Tesla. Teslas have a lot more code in them. I'm just a normal old car nowadays. 100 million lines of code, most of which, of course, is in the entertainment system and the GPS system. But some of that code is actually sitting between your foot and the brake, because, you know, the anti-lock braking systems and the anti-skid braking systems will control the brake despite what kind of pressure you put on the foot pedal. There are if statements sitting between your foot and the brake. There are if statements sitting between your other foot and the accelerator. The car controls the engine with software, and you control the software with your feet. Some of us even have cars that can control the steering wheel with software. You think about that for a while, it should scare the heck out of you. How many people have died because the software in their car malfunctioned? And the answer to that is many dozens. There have been many dozens of people who have been killed by the software in their car. Many, many hundreds have been injured by the software in their car. You and I are killing people. Now, we didn't get into this business to kill people. Most of us got into this business because we managed to write an infinite loop once that printed our name, and we thought it was just so cool. But now we write the code that kills people or loses fortunes. How many fortunes have been lost because some software guy did something dumb? Like the guys at Night Capital, you might know this story. Sad story, took place about 6 or 7 years ago. Some software developers did something just a little bit dumb, just a little bit dumb, and lost $450 million in 45 minutes. The company they worked for disappeared as an entity, was purchased out from under the CEO in a matter of minutes. just a dumb little thing. You and I are suddenly in a position where we control just about everything. You and I rule the world. Other people think they rule the world. Then they hand the rules to us, and we write the rules that run on the machines that govern everything. Because nothing happens in our society without software being right in the middle of it all. There's nothing you can do in our society without software being in the middle of it. You can't even cook dinner without software being in the middle of it. You can't drive to the store. You can't buy anything. You can't sell anything. You can't pass a law. You can't enforce a law. You can't get insurance. You can't file a claim. There is nothing you can do. You can't watch TV. You can't make a phone call without software being right smack dab in the middle of it. You and I control the world, and that should terrify you. It should really terrify everyone. Because the people who are controlling the world, you and I, do not have a profession. We don't have any standards. We don't have any ethics. We don't have any named disciplines. The whole world runs on the code that we write, and that's all done without professional disciplines. So here I am, and I'm going to tell you what I expect out of professional software developers. I, your new CTO, am going to list the expectations. Now, you are going to hear these expectations with both of your ears, but one of those ears is the ear of the programmer. The other ear will be the ear of the user and the customer. And to the programmer's ear, the things that I'm about to say will make no sense at all. But to the ear of the user and the manager and the customer, they will make perfect sense. And let me just begin. I expect from everyone here, from all of you programmers, I expect that we will not ship shit. Now, this is not a difficult expectation to say. And certainly the managers and the customers and the users fully expect that we will not ship shit. But the programmer in you is rebelling already, saying, well, we have to ship shit. We're programmers. It's what we do. How many of you out there have shipped shit in your life? I certainly have. Many of us have. We have grown up in an industry where shipping substandard software is normal. When did it happen that people started shipping beta? You know, beta testing, beta versions, you know what beta really means? Beta is when you get a very small group of testers and you ask them voluntarily to please test this horrible code before I ship it. That's what a beta test was supposed to be. Nowadays, we just ship betas. We just put a little note on the website. By the way, this is a beta, might crash, might erase everything on your disk. Use it at your own risk. We don't have disks anymore, do we? No, we don't. So we are not going to do this. Our first discipline is that we will not ship shit. We will make sure that what we ship actually works. How are we going to do that? How are we going to make sure that the code we ship works and is maintainable and flexible and changeable? There's several different kinds of shit that we can ship, of course. We could ship shit that just crashes all the time. That would be bad, or doesn't behave. It's got lots of bugs. That would be bad. But there's another kind, which in many ways is worse. And this is the bad code that programmers ship to each other. I write code to you, and you look at that code and go, oh my God, that's shit. That's bad. We don't want to ship that bad code to each other. What we want is to be able to ship code that is solid, well-written, easy to maintain, flexible, and works. Now, many of you out there are saying, yes, but we don't have time. Our schedules are such that we just have to ship shit. No, you don't have to. You don't have to. No one is expecting you to ship terrible code. No one expects that. If you go to all your managers, you go to all your users, go to all your customers, and you ask them, hey, do you want really bad code? They're going to tell you, no, we don't want really bad code. Now, of course, they also want it by a certain time, but they don't want it to be bad. You and I are going to have to figure this one out. We're going to have a way to deliver in reasonable timescales reasonably well-developed code. That's just the first expectation. Let's move on to the second. I expect that we will always be ready to ship. Now, that may sound like a contradiction, but it's not. I expect that we will always be ready to ship. And by always, what I mean is very frequently. I presume that many of you out there are doing some kind of agile. That's the thing now. We all have to be doing some kind of agile. It's probably Scrum or something like that. Fine. All right. Well, if you are doing some kind of agile, then you are probably delivering once every 2 weeks. That seems to be the normal sprint size now, 2 weeks. Some of us do 1 week sprints. Some of us do 3 week or 4 week sprints. That's too long, by the way. 2 weeks is better. I actually prefer 1 week, but okay, 2 weeks. Let's say 2 weeks. Every 2 weeks, you should be ready to ship, which means that what you're shipping cannot be shit. Every 2 weeks, you must have good code ready to ship. By the way, this is just standard Agile stuff, right? Every iteration, you should be ready to deploy. Now, you may not have enough features to deploy. That's a business decision. The business people can make that decision. The business people may decide, oh, we should not deploy this because there aren't enough features in it. That's fine. That's a business decision. But from our point of view, from the programmers and the QA point of view, it's ready. Maybe you can log out, but you can't log in. We don't have all the features yet, but the stuff that we've written is ready to deploy. Let it be a business decision if they want to deploy it or not. But we are not going to be the ones who say, you cannot deploy yet because it's technically unsound. We will not be in that position. Once every 2 weeks, or maybe once every 1 week, if you want to go that fast, we will be ready to deploy. That means that all the testing is done, all the documentation is done, that for everything that's in the system so far, that all the burn-in is done. Everything that we would do to make sure it's ready to deploy is done once every 2 weeks or so.
Sorry, Uncle Bob, I think that we are seeing the PowerPoint file, but not the presentation.
Oh, do you see the words, we will always be ready?
No, we see the first slide only. So probably only the file is shared and not the full thing.
Let's see. Okay, hold on.
Yeah.
Your
Sorry for
screen sharing
interrupting.
is paused. Resume share. Oh, there we go. Okay. Something happened in the middle, and now it is sharing. Do you see it now?
Yeah, it's fine.
We will always be ready. You see that? Okay. And so let's see. You saw this one. We will not ship shit. You saw this one. We will always be ready. Good. Okay. Yeah, just yell at me if anything goes wrong. You know, these Zoom things, you never know what the devil's going on half the time with these. All right, next. I expect stable productivity. Stable productivity, what does that mean? That means that you will go as fast tomorrow as you went today. You will go as fast next year as you went this year. Now, why do I say that? If you've been working in software for more than a couple of years, then you have seen software teams slow down. You have seen them begin at high speed, high productivity, and then over a few months or years, they get slower and slower and slower. And why do they get slower? Because the code gets messier and messier. If you've been a programmer for any more than a couple of years, you have been slowed down by bad code and significantly slowed down by bad code. I've worked in teams where it was impossible to get anything done in a time frame shorter than 6 months because the code was just so bad, so complicated, that no one was willing to give an estimate any shorter than that. I don't expect this. I don't expect your productivity to get worse and worse with time. I expect your productivity to remain constant, if not increase, but generally remain constant. I don't expect you to write code that slows you down over time. How many software teams move at a snail's pace because the code is so bad? And it's an awful lot. There's an awful lot of software teams out there that are significantly impeded by bad code. Why did they write it? Why did they write the bad code? Well, they wrote the code in order to go fast. They wrote the bad code in order to go fast. And of course, what they wrote is what slowed them down. I will leave you to deal with the logical inconsistency of that. But I want you to focus on something different. Every bit of bad code in the system slows you down and slows everybody else down every time they see it, anytime they have to touch it, anytime it runs by their screen, anytime they scroll past it, it slows you down. Everyone gets slowed down by bad code over and over and over again. It is a perpetual friction. It is like pouring molasses all over the code. It makes it hard to deal with. And I don't expect that. I don't expect the code to get worse with time. I don't expect you to slow down with time. I expect stable productivity. You might be asking how you can do that. Well, I might just be getting to that. Hold on a moment, because I expect something else. I expect inexpensive adaptability. What does that mean, inexpensive adaptability? It means that when the customer changes their mind, it will not cost them a fortune. That's what it means. And by the way, customers are going to change their minds. Customers change their minds all the time. That's why we have software. We have software so that customers can change their minds. Software is a compound word. It comes from two words, soft and ware. The word ware means product. The word soft means soft, flexible product. That's what software means. To the extent that you make software that is hard to change, you have turned it into hardware. We don't want hardware. We want software. When customers come to us with a change in requirements, that change should not cost them a lot. Or, better way to say that, the cost of the change should be proportional to the scope of the change. If the scope of the change is large, the cost will be large. If the scope of the change is small, the cost should be small. The problem is that very often software developers invert that. They create a design or an architecture or just a plain old mess that causes them to amplify the cost of change, even though the scope of the change is small. How many times have you worked on a project where the customers finally come and say, you know, we'd like this one small thing changed, and everybody goes, oh my God, that ruins everything. That corrupts our architecture. It's not really a small change. You don't understand. It's a huge change. And the customer doesn't understand that. In the customer's mind, it's a small change. If the customer's view of change and your view of change are different, there is something wrong with your design. Because the customer's view of change and your view of change need to be the same in order for the customer to get the benefit of inexpensive adaptability, in order for the customer to get the benefit of software. Next expectation, I expect continuous improvement. I expect absolutely everything to get better with time. I expect the design of the code to get better with time, the quality of the code to get better with time, the feature set to get better with time, the documentation to get better with time, the architecture to get better with time. I expect everything to get better with time because we are human beings, and that is what human beings do. Human beings make things better with time. I know, we're all talking about, no, they don't. Human beings ruin everything. No. There are many things that human beings do that might not be optimal at the moment, but in general, human beings make things better with time. And I expect that you as programmers will always make things better. I have a simple rule for you. It's called the Boy Scout rule. Every time you check the code in, you check it in cleaner than you checked it out. Every single time you check the code in, you check it in cleaner than you checked it out. Imagine if everybody did that. If everybody followed that one simple rule, the code would get better and better, the designs would get better, the architecture would get better, everything would get better with time. Nobody would slow down. We would have stable productivity. We would have inexpensive adaptability. We would not ship shit. If everybody simply made things better with every single check-in, we would have all of these other expectations met. How? Fearless competence. I expect fearless competence. Now, what is that fearless competence? Well, let me describe the opposite to you, and then perhaps you'll recognize it. The opposite is fearful incompetence. Imagine that you are looking on your screen and some code scrolls up, and you look at that code and you realize that it's awful, it's terrible. And the blood drains from your face and you think, oh, this is awful code. And a thought bubbles up to the top of your brain and you think, I should clean this code. But then another thought asserts itself immediately, I'm not touching it. Because you know if you touch it, you will break it. And if you break it, it becomes yours forever. And so you back away. No, I'm not going to be the one to clean that code. Someone else can clean that code. It won't be me. And of course, everybody behaves the same way. That is fearful incompetence. Fearful incompetence. You are not competent to clean the code because you are too afraid to clean the code. And I submit to you that if that is the way you react, then nothing will make that code better. All that will ever happen to the system is that it will rot. It will get worse and worse and worse with time because no one is willing to do the one thing that could improve that code. Clean it. How do you get rid of the fear? It's the fear that's the problem, isn't it? You look at the code and you are afraid. You are afraid to clean it. You are afraid to make it better. I want you to consider how wildly irresponsible that is, how incredibly unprofessional it is to be afraid of the very thing that you have created, to allow it so far out of your control that you are fearful of doing the one thing that might save it. How do we deal with that fear? How do we eliminate that fear? I could suggest something to you. I mean, maybe you've got a better idea, but I could suggest something to you. Imagine that you had a little button sitting right next to your laptop, just a little button. And whenever you push that little button, some lights blink and some computer kind of sounds come out, and then a little green light lights up within seconds. And that little green light means that everything works. All the code works. It all works fine. If you had that button, how would it change how you behave? How would it affect your fear? Imagine that the code comes up on your screen and it's terrible. It's awful. It's horrible code. And you think, oh my God, I should clean that code. What is your next thought? And your next thought is, maybe I could change the name of that variable. Push the button. Oh yeah, green. Okay. That function is a little large. Maybe I could split it into two. Give it a better name. Yeah, push the button. Still green. Good. That function there probably belongs in this class over here. Push the button. Ooh, turned red. Put it back. Put it back. Push the button. Green again. Oh, I see what I did wrong. I need to put it over here instead. Push the button. Still green. If you had that button, you would clean the code. If you had that button, you would be fearlessly competent. If you had that button, you would constantly improve things. You would make things inexpensively adaptable. You would not chip shit. If you had that button, how do you get that button? Now you need that button, don't you? You really want that button, don't you? Is it possible to get that button? Can you get that button? I'm not going to tell you exactly how. That would be a different course that I would teach. I will name one of the disciplines for you, one of the professional disciplines that might just get you that button with a little bit of effort, a little bit of practice, a little bit of acquired skill. You might just be able to get that button. And the name of that discipline is test-driven development. You can look that up. You can search for it. You can see all of the talks that I have given on it and the talks that other people have given on it, the books that people have written about it. You can study this discipline. And if you practice it and acquire it and get good at it, you might just get that button. I've had that button. Let me tell you, I'm never living without that button again. I will never make a software system that does not have that button. You might want to get that button too. But my expectations of you are not complete. There is more. I expect extreme quality. I expect that everything works all the time. I don't expect bugs. Why would anybody expect bugs? When did we as an industry decide that bugs were normal, that bugs were expected? That of course there's going to be bugs, it's software. When did we decide that? I don't expect that. I don't expect bugs. I expect the software to actually work. Imagine that. I expect the software will actually work. Now, are there going to be bugs from time to time? Well, I suppose, we're all human, we're all fallible. There are probably going to be an occasional defect. Where do you keep them? Where do you write your defects down? You know, those defects that occur so seldomly. Where do you write them down? Do you keep them in an automated database? Are there really so many that you have to keep them in an automated database? Something that can sort and search? Is that how many you have? I don't want you to have that many. You should be able to list all the defects in your system on a 3x5 index card, or at least a page, one page, not 2 pages, one page. You don't want to have that many defects. And we certainly don't want so many that we have to keep them in some kind of horrible automated database. Yes, I know, all the Jira people out there. You should not be having a bug tracking database. I expect extreme quality. In fact, I expect so much quality that we're not going to dump terrible crap on QA. We're not going to just dump our code on QA and have them figure out what's wrong with it. We're the developers. We get rid of the bugs. In fact, I expect that QA will find nothing. I don't want QA sweeping a whole bunch of bugs back to me. Every time I deliver to QA, my expectation is that they will not find any bugs. And if they do find some, I want to find out what went wrong so that never happens again. QA should not find anything. In fact, I don't want QA at the end of the project at all. I don't want them testing it at the end. I want to change the rule. I want QA to be put at the beginning of the project. I want QA writing the tests that prove that the system works properly. And I want the developers to run those tests. I don't want QA to run the tests. I want the developers to run those tests. And of course, I want all those tests to be automated. It's just nuts not to have automated tests. Here's the a picture. The hands you see are the hands of a QA manager. The year is roughly 2008. And he's holding out to me this big document. That big document that you see in his hands is the table of contents for his manual test plan. It is not his whole manual test plan. It is just the table of contents. He has 80,000 manual tests that he must run every 6 months. He sends those manual tests over to an army of testers in India, and it costs him $1 million every 6 months to run those tests. He's holding it out to me because the year is 2008 and the financial crisis has begun, and his boss has told him that his budget is being cut by 50%, and he's asking me which half of these tests he shouldn't run. I told him, well, it doesn't matter how you cut that document. You can cut it lengthwise or crosswise or depthwise. You're not going to know if half of your system works. Manual testing always ends up with you losing the tests. There's no other way around it. If you do manual testing, you will lose the tests because the tests become too expensive to run. If human beings are involved in the running of the tests get too expensive to run. You might lose the tests the way this guy lost the tests, because that's a pretty common way. You know, some accountant finally says, that's too expensive, we can't afford it, cut the budget. But there's another more insidious way that you lose the tests, and it has to do with the fact that QA runs out of time. QA knows how long it takes them to run their tests, but the developers often deliver late. And because they deliver late, the QA doesn't have time to run all the tests. And so then QA has to make a decision. They decide which tests to run. They do that by choosing the tests based on whatever changed. And of course, that means they're not going to run all the tests, and you will lose the tests that they did not run. One way or the other, if you test manually, you're going to lose your tests. I don't expect that. I expect QA to find nothing and extreme quality. I expect nothing fragile in the system. I do not expect there to be modules that are the ones that always fail, or the ones that everyone is afraid to go near. I expect every part of the system to be robust. I expect that we, as software developers, will cover for each other. What do I mean by this? Imagine a team of players on the field, moving the ball down the field. They're working against the offense. They're working against the defense. They're kicking the ball back and forth to each other. They are passing it left and right. They're moving the ball down the field towards the goal. And then one of those team members falls, trips, goes down. But the referees do not stop the play. What do the other players do? They change their positions to cover the hole and keep the ball moving down the field. That is how a team behaves. Are we a software team? If we are a software team, we must learn to cover for each other. When one of our teammates goes down, we should be able to cover for them by taking over the tasks that had been assigned to them or that they were working on. How is it that we could do that? Let's say that we've got a team of 6 or 7 guys, 6 or 7 programmers, and one guy does doing the database, and another guy's doing the GUI, and another guy's doing the middleware, and somebody else is doing something else, and one of them gets sick and can't come into work for 5 days. What do? Well, we change our field position and keep the ball moving down the field. Someone is going to have to take over some of those tasks. How? How are we going to cover for each other if we're all too busy working on our own stuff? We cannot all be too busy working on our own stuff. We're going to have to somehow share knowledge. One of the ways to do that, of course, is to program with each other. Pair programming or mob programming. Not all the time, just enough so that knowledge moves through the team and we can cover for each other if someone goes down. I expect that the team will survive and the team will react well when someone goes down. I expect that we will cover for each other. This one probably surprised you. I expect honest estimates. What is the most honest estimate you can make? 3 little words. I don't know. That is the most honest estimate you can make because you don't know. If someone shows you a software task and asks you how long it's going to take, you don't know. And don't pretend that you do because you don't. But I don't know is not a useful estimate. So you're going to have to change it to a description of what you don't know. And there's a way to do that. For example, one way, very common way, is for you to provide 3 numbers for every estimate. Someone says, okay, how long is this going to take you? And you say, well, if everything goes right, and I mean, everything goes right. You have the right breakfast cereal in the morning, and your coworkers are always polite and happy, and there's no emergencies anywhere, then this is going to take me 5 days. But if things go the way they usually go, with lots of disturbances and things like that, and meetings and silly nonsense, well, then it's going to take me 10 days. And if things go the way they might, if they go really badly, well, then it might take me 30 days. Might be 5, might be 10, could be 30. That's an honest estimate. That describes the shape of what you don't know. It defines a probability distribution that your managers will have to deal with. You know how managers deal with probability distributions? They have to do this thing called management. It's what management is. Management is dealing with probabilities. It's dealing with uncertainty. We cannot provide certainty unless we have it. So when we provide estimates, those estimates have to be honest. And that honesty is some description of what we don't know, some shape to our uncertainty that is their job to deal with, not ours, theirs. We must communicate the uncertainty. They must manage the uncertainty. And I expect that when the answer is no, you will say no. Someone comes to you and says, this has to be done by Tuesday. And if there is no way to get it done by Tuesday, you must say no. You were hired because of your ability to say no. You are the person who has the knowledge to know when the answer is no. They don't, you do. And you will save your company massive amounts of money and embarrassment if you say no at the appropriate time. Now, I don't expect you to go running around saying no, 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 no all the time. But when the answer is no, you must be able to say no and stand your ground. No, this cannot be done in that amount of time. No, it cannot be. And now I want you to watch out for something. Because managers are very good at getting into your head. And they might do something like this. They might ask you to at least try. And the word is so seductive, the word try. Will you at least try? How could you possibly refuse? But you must. You must look at that in a different way. You must look at it as an insult. How dare you accuse me of not trying? I'm already trying. Now, don't say that. It would not be a good idea to inflame passions and actually say those words. But that's what you should be thinking. How dare that manager accuse me of not trying? I'm already trying. I haven't been holding anything back. Don't say that out loud. Instead, simply say, I'm sorry. We are already trying. There's nothing more we can do. The answer is still no. You know, an awful lot of the troubles we've had in software is because programmers who should have said no didn't say no. I expect continuous aggressive learning. I know I'm preaching to the choir here because all of you are here because you are continuously and aggressively learning, but I still expect continuous aggressive learning. Our industry is an industry full of change. We could argue whether that change is necessary or not. Some of us might think that it's not necessary change nowadays, but we are still changing. We grew up at a time when that change was forced upon us. I grew up at a time when I was using that computer that's sitting behind me, that one with the little blinking lights. It had a cycle time of 2 microseconds, a half a megahertz clock rate, 2 microseconds cycle time. We thought that was blazing fast. It had 4K of core. We thought that was a lot of memory. It didn't have a disk. Why would you need a disk? Nowadays, we have massive machines, incredible machines that are so much more powerful than that machine. You can only describe the difference in orders of magnitude, and the orders of magnitude are large. We have seen immense change over the last 50, 60 years. And so we've come to expect that change. The change, by the way, has stopped. We're on the plateau now. Moore's law ended a decade ago. Clock rates are not getting faster. Memories are not getting bigger much. The doubling rate has stopped. We are no longer on the exponential curve. The hardware is not changing much anymore, but the software continues the momentum. We haven't let go of the momentum. We want things to change. So there are new languages and new frameworks and new things all the time, and you're going to have to keep up with them. You're going to have to always learn whatever is new coming down the pike. You can't get behind. You can't sit there and go, well, I know Java and Java is good enough. Nope, sorry, you're going to have to learn Ruby. You're going to have to learn Python. You're going to have to learn Go. You're going to have to learn Rust. You're going to have to learn Elm. You're going to have to learn all these things, and you'll have to internalize them because the page can turn fast and you could be left behind. Always learning all the time. One last expectation, and then we're done. The best way to learn is to teach by an immense margin. If you want to learn something, teach someone else, and you will learn the thing that you are trying to teach. This is mentoring. The old people listening to me, people with 5, 6, 7 years experience, teach the new people, people with 2 and 3 years experience. Those of you with 10 or 15 years experience, teach the ones with 5 years experience. Teach, mentor, train each other. The schools have not done a good job of this. The universities have not done a good job of this. The only thing that is really going to bring the next generation into this industry properly is you and I teaching them. So take some people under your wing and teach them. Consider that a responsibility. Don't just hide in your office and write code. Find someone who needs to learn and help them learn. And with that, I think I'm done with all my expectations and all my preaching. I'm grateful for your attention. Thank you very much. I'm going to stop sharing my screen so that you can see my lovely face and ask if there are any questions. Now, to deal with the questions, I think maybe what we'll try to do is the hand raising trick. So if you know how to raise your hand, you can raise your hand and then I will call upon you and you can unmute yourself and talk to me. Or if you wish, you might want to type a question into the chat. I'm not sure that that will work all that well, but in any case, I see a hand up. Nikolai, I see your hand up. Go ahead and unmute yourself.
Hi. The one question, you're talking about this situation that you don't have a certain knowledge of how long it's going to take to implement the task. So like 5 days, 10 days, and 30 days. But what if you have different ways of implementing the task? You can do it in a bad way. You can quickly make some that dirty code, and that would be good for the business because they need it tomorrow, right? Because they have a big contract. If you don't do it, they're gonna, yeah, they need it to that. And then you can fix it next week. What about this situation? How are you gonna solve this? And
so, well, you certainly know that next week never comes, right?
I don't know.
You never get to go back and fix anything. That never happens. And you have to look at it that way. You can't say, well, we'll go back and fix it later, because you very likely won't. And the reason you won't go back and fix it later is that managers will come along next week with the next thing that has to be done in a short time frame. So you, as the developer, have to look at the cost and communicate the cost of that bad code going into the system. And that cost is large. Right? You have to make sure that managers understand this is going to slow us down. If I put this code in today, then for the next several months, everyone else is going to slow down. And the next time you ask me for something fast, I won't be able to deliver it. Now, sometimes there are business exigencies that absolutely must be met, and you've got to break all the rules to meet them. That happens. But you, as the developer, have to be able to communicate extremely well to the business just how much that is going to cost them. You also need to stand up for your rights as a stakeholder, because you are a stakeholder. Your reputation is on the line. And if you're putting bad code out there, everybody else is going to think, oh, what kind of schlock programmers do we have around here? Your reputation is on the line just as much as the business. So you need to be able to push back. We programmers are not good at emotional confrontation. We don't like dealing with people. We didn't get into this business because we like dealing with people. We like dealing with our machines because machines are predictable, right? people, they're odd. But there are people who do like dealing with people. They tend to be either salespeople or managers. Managers are good at dealing with people. And one of the ways they deal with people is through emotional confrontation. If you've got a microphone on, turn your microphone off. One of the ways they deal with people is through emotional confrontation. Managers often find the truth by emotionally confronting you and seeing how you react. And we as developers have to be able to deal with that and convince them emotionally that the cost to the business is going to be very large. I sat in a meeting once, this is a long time ago, and I was just a programmer, and it was a meeting about how we were going to distribute the resources. It's always a problem, right? Which people are going to work on which project in order to get this thing done by that time and this thing done by that time. Terrible problem. I had been given the task of serving one particular customer, and that customer had a deadline, and I needed to get to that deadline. And in this meeting, the managers in the meeting were starting to talk about removing resources from me and scattering them to other teams. And I realized that I was going to lose my deadline. I was not going to be able to satisfy my customer. And I threw a fit. I usually don't do that in a meeting, but I literally threw a fit. I started yelling at them and telling them, you can't do this. You are begging the lightning to strike. That's a quote. You are begging the lightning to strike. And they all sat back, and all of a sudden there was this new respect in their eyes. And they said, well, you've made a very good point. I made no point at all. I just made this emotional ejaculation. I didn't give them any logic. I didn't describe why it was going to be bad. I just told them it was going to be bad. And emotionally, that convinced them all. And they left me alone. I learned in that meeting the power of responding to emotional confrontation. That's the long answer to a short question. Thank you for that one. Anybody else with a question? Raise your hand. Oh, George, unmute and go.
Hello, can you hear me?
George, yes, I hear you.
So let's suppose that somehow you are getting access to our Git. You are getting access to our code base. And the programming language is a programming language that you are familiar with. You are able to understand the syntax and everything. And you have 1 hour to read the code, to browse the code without checking it out, without opening it in your IDE. What kind of things would you like to see in the code base, and that would get you to say that this code is good, or it's not clean as per your own standards, but it's in a good direction, let's say. Thank you.
The things that I would look for, if I only had an hour and I couldn't get it in my IDE, so I was simply looking at the source code on Git. The things that I would look for would be simple things. How big are the functions? Are the functions large or are they small? I want to see small functions. I want to see functions that are 5 lines long, 8 lines long, 10 lines long at most. I want to see if those functions are well named. I want to make sure that there aren't too many arguments in any of those functions. I want to make sure that when I read a function, it reads like well-written prose, that it's not loaded with Boolean expressions and lots of complex arithmetic, but instead it's a nice statement of other function calls that have nice names. I want to make sure that the classes are small and that there are many such classes. And I would look at the number of fields in the classes and the number of methods in the classes and the number of relationships that the classes have and how those classes are named and what namespaces they're in. What I would be looking for is the signature of professionals at work, that things are well organized and well named and well structured. It's easy to look in a code base and see whether or not the programmers have been orderly and disciplined or whether they've just been throwing code all over the place. And perhaps the first thing that I would look for would be a suite of unit tests, a nicely comprehensive suite of tests that guide me through the logic of the system. If I can start at a test and understand the test and then understand how the code being tested passes the test in a nice, simple, orderly way, then I would feel that professionals had been at work. That's the answer to my question, to your question. All right, George, put your hand down. And anybody else have a question? Unless, George, you have another question. Okay, oh, let's see, Andreas. Oh, got two hands up.
Nikolai can start if he wants.
Okay, I just wanted to wait until somebody else decided. But if nobody else, then I have another question. Yeah, it's about tests again. Yeah, because I had lately the creator of the TDD, Ken Beck. He told that with his experience of working in Facebook, yeah, he came into the conclusion that you don't have to write like until 100% coverage in a unit test every time. It depends on the situation. The most important thing is to have this, which is called feedback, probably your green button. It's not necessarily tests, it's maybe something else. Yeah, and actually, can you just keep doing the test if you making a good architecture? Well, I just need to elaborate here, because well, we don't do tests actually, and tests, and well, I think probably why do you need tests? You just make some changes when you introduce new feature, and then probably you see, okay, and it happens, you just break something else somewhere, and you made one good thing, and it introduced two bugs, and you're not moving somewhere. Probably it's because everything is connected, and it's too much connect. Maybe you want to split some code, make different models, and then if you change one model, it's not going to affect another part of this code base, and then probably you don't need so much tests in this case. Can you just mitigate it with the right splitting your code through different models and submodels and all the structure somehow, at least? Yeah, it's funny.
Okay, so we're going to start at the beginning of that one. The beginning of that was Kent Beck at Facebook, and Kent Beck came to the conclusion that you don't need tests for everything, which of course is absolutely correct. You don't need tests for everything. And there are several things that in a software environment that are so difficult to test that it's not practical. For example, the GUI. GUIs are hard to test. And in some sense, they're impossible to test unless you put a camera up and somehow digitize that camera, which I don't expect you to do. There are many places in the code that have that aspect with it. They are difficult to test. All right. Well, what you want to do then is pull as much code out of those areas so that you leave those areas fairly devoid of complex code, and then you can test the rest of the system. And that was really what Kent Beck was getting at. You cannot test everything, but you do want to test the stuff that you can test and that is most important to test. Then you went on and you changed the nature of the question and started talking about breaking up the model of the system. And I suppose what you were getting at there is that if you have a large suite of tests and then you want to change the architecture of the system, you are going to break all those tests. And so those tests are going to enforce a kind of rigidity on your architecture. That is a very common problem amongst new test-driven developers, because they design their tests in a way, well, actually, they don't design their tests. They design their tests, or they allow their tests to have a form that makes the architecture of the system rigid. In advanced test-driven development courses, what I teach is the design approach to allow the tests to remain independent of the architecture of the system. This is really important because you're right. If you have 10,000 tests and they anchor the architecture of the system, then if you change the architecture of the system, thousands of tests are going to break and you're just going to throw them away at that point. So it's very, very important to treat the tests as a designed part of the system so that it does not anchor the rest of the system, does not make the rest of the system rigid. There are techniques for doing that. There are patterns for doing that that we can talk about in a much more elaborate environment than this one.
Sorry,
In fact, I'm just writing a book about this right now.
Actually, well, I meant something different a little bit, because yeah, I'm just trying to find a way how to don't write tests at all. I mean, yeah, well, that's might be funny, because yeah, actually you have a model, right? And you make some changes. And next time you find that because you made changes in this model, and because you have some dependency on in another part of this model, probably on in a different model, and this dependency led to the bug. And so next time you understand, okay, probably you don't need this dependency. You just break this dependency. Don't write any test, just break dependency, and then you don't introduce this bug next time, because this part, this should be absolutely your own thing and don't have so much dependency. And then, yeah, that's the idea actually.
Why would you not want to write tests?
Well, because you have to write something.
Okay, so
you spend your time.
You spend your time doing what?
Doing writing the tests, actually.
You spend your time thinking through what the software has to do. And you express that thinking through in code, the best possible language to express that in. Why would you want to express that in some other language?
Oh, I know. Actually, if you save your time in the future, you definitely should write the tests. You must be able to somehow to measure this, probably, if it's possible.
Yeah. Oh, yes. Yes. Does it save you time? Again, I can go through all the reasons why writing tests saves you an awful lot of time. Certainly saves me an awful lot of time. But let me take a different approach with you. Why do accountants enter every transaction twice? They use a discipline called double entry bookkeeping. And they enter every transaction once on the asset side and once on the liability side. They follow separate mathematical pathways until they finally get a subtraction on the balance sheet that must yield a zero. This is a matter of law. In almost every country on the planet, accountants are legally required to enter every transaction twice and then do a subtraction to get a zero on the balance sheet. Why do you suppose that is? And why would that not be important for programmers to do? Given that our society now depends on software for its existence. I'll leave you with that concept. Anybody else got a question?
Yeah, can I ask?
Yeah, go right ahead.
So this is a question from Zenon Chrysostomou. He basically asks, for startups, how should we manage speed versus quality of code? At which point of the project should we switch from delivering functionality quickly to properly writing the code?
One of the things you learn as you get older is that there's no tension there. If you want to go fast, you keep your quality high. The best way to slow down is to write a mess. If you want to go fast, don't write the mess. And by the way, your grandmother told you this years ago, right? Anything worth doing is doing well, you know. Older people tend to look at that and go, no, you don't go fast by making a mess. We all learn that as we get older. The bigger mess you make, the slower you're going to go. So you never make that trade-off. You always do a good job. Always do a good job. Always write the code the best you can. Always make sure it's as clean as possible. That will guarantee that you are going as fast as possible. It won't feel as fast as possible because young people think that they're going faster when they are rushing. Older people understand that when you rush, you actually go slow.
I can understand the question a bit different as well. I get it that when you are a startup and you don't have a product yet, or it's not that mature against the competition, you want to get it out there, the functionality, as fast as possible first, just to get that initial feedback on the features, and then based on the feedback, you might need to pivot or change ideas or change stuff. So this is how I perceive that question, more or less.
Yep, I did too. And everybody wants to go to the startup question. Oh, in a startup, we have to rush. We have to get our features out fast because we need that feedback from the market. That's true. It's absolutely true. So what is the fastest way to get those features out? Do a good job. If you want to slowly get the features out, make a mess. If you want to destroy your startup, then make a mess. If you want your startup to succeed and get those features out fast, do a good job. I know about 2/3 of you out there don't believe a word I just said, but you will. You might have to get some gray hair first. I've got to go, guys. It's time for me to vacate these premises. Thank you all for your attention. I had a lot of fun with this one.
Thank you.
Thank you very much, Robert.
All right.
Thank you. Bye-bye.
Bye-bye, everybody.
Thank you. Bye.
Thank you. Bye.
Bye.
Bye-bye.
All right.
Mom, here's